Fighting Noise, a nonoise podcast. Have you seen that noise? Great question, right? Invisible pains like air pollution or noise pollution are difficult to communicate. You know it's noisy, but it's sometimes hard to identify where it comes from. Hard to identify the right solution. Today in Fighting Noise, my guest is Thomas Rittenschober from Seven Bel, an Austrian startup having a solution for that. Hi Thomas, nice to have you here.
Hi Julien, nice to meet you. Nice to have me on the podcast.
That's really nice to be here from live from Linz, I guess. Thomas, first question: why is it so difficult for a human ear, for a human brain, to identify where a noise comes from?
Okay, so we're getting right into the technical details of sound localization. Good with me. The way humans identify where sound is coming from is essentially based on time differences between when a sound wave hits your left or right ear, or the other way around. And the distance of our ears is essentially specifically tuned to human speech. So we are well at identifying where sound is coming from when people are talking, or when we want to locate high frequency sound. But when it really comes to identifying lower frequency sound events like sound emissions from plants or machines, these type of sound events are very difficult for humans to identify, because you would need to have a much wider distance between your ears or microphones, so to say. And this is exactly where an acoustic camera comes in, and why measurement instruments are far more capable than the human being in this case, in terms of exactly locating where a specific sound event is coming from.
You're right, we are starting quite technical, so today would be an episode for engineers, I guess, but I think for everyone in the manufacturing or real estate industry as well. But let's start with yourself. Can you introduce yourself, Thomas?
Yeah, so first of all, thanks again, for having me today. My name is Thomas Rittenschober. I'm the founder and general manager at Seven Bel. We are a manufacturer of high-performance acoustic cameras. So these are measurement instruments that are specifically used by industry professionals, mostly engineers, technicians, used in the context of locating sound emissions from products and processes. And
We'll deep dive into this. We'll deep dive into this, but maybe starting with yourself. What's your journey? What's your why? We'll go deeper into the solution for sure, but understanding why did you develop that solution?
Yeah, so it started.
So
we have to go back, like I would say, almost 15 to 20 years. After university, I joined a research institute where I focused on reducing sound emissions from products and processes. Back then, I've already started using quite elaborate or quite expensive measurement instrumentation for gathering data around, sound events, vibrations, etc. And that's actually a topic that I've really developed a passion for. So my background is actually in mechatronics. So trying to design products in terms of mechanics and electronics, and also information technology. But then after that, after my study, and when I focused on my PhD degree, I really dig deep into trying to understand how products and processes emit sound, and what you can actually do in order to control that sound. And then this is where I first got in touch with these delicate measurement instruments called acoustic cameras. So that was actually the first stint of my professional career for about 7 years, where I essentially developed a high performance solution for reducing sound emissions from products and processes. And then I headed on to more industrial applications. So I joined a company, General Electric, in their medical ultrasound business. So also there it was somewhat very similar what I did, not in the audible range, but in the non-audible range, ultrasound range, using pulse ecosystems for essentially generating medical ultrasound images. And beyond that, I eventually decided to found my own company and get back to the audible frequency range again. And I've somewhat screened the market, tried to understand, what has happened since then, how have acoustic cameras evolved. And I still, what I identified was essentially that these products were somewhat still lab-based systems, expert systems. And I thought that it might be worthwhile to try to understand what it takes to make these measurement instruments or how to modify those systems to make them compatible with mainstream applications. Not only on the cost side, because these products were typically very expensive and are still very expensive, but how to make them essentially more compatible with mainstream applications in the industry. And that's what I've been doing for the last 8 years now. Yeah.
For the last 8 years. So tell us about Seven Bel, startup from Linz in Austria, where a lot of innovation is happening actually in Austria. For the audience not being aware about the active Austrian market, tell us about Seven Bel. You are developing a sound camera like this to localize sound in every space. Tell us a bit more about that and maybe about the use cases behind you want to solve.
Yeah, sure. So I founded the company in 2018, and it took us some 3 years to develop the technology. It all started out with, trying to understand what it takes to build an acoustic camera with only a minimal set of microphones. So it was actually all based on the concept of frugal innovation, which essentially means I just give you a very scarce set of resources, and you're tasked to essentially achieve maximum performance with that, and beating essentially the performance that is currently available or what is state of the art. So this is actually how the whole challenge started in 2018, and it was quite tedious. It took us some time, to really figure out and get to the performance that was essentially at the level where we said, okay, now we are ready for the market. We obviously had the support from national funding agencies and also private investors, venture capitalists to make all of this happen, because at some stage it's not only the concept that you want to implement, but there are a lot of components, both on the hardware side and software side, to eventually create the product and also eventually also bring it into the market. And that was happening in 2021. When we eventually launched the product. And the areas where we initially focused on were building acoustics, room acoustics, and environmental noise. So our initial customers were mostly from the acoustic consultancy space. So experts that are confronted with acoustic challenges in their daily life, who obviously have expertise in the field of acoustics. But at some stage, when problems really become tricky, you want to rely, and you don't want to rely on hypothesis only. You essentially resort to an acoustic camera and really kind of visualize, what is happening and where the sound is coming from in order to make grounded engineering decisions thereafter.
We'll add some pictures on our video on this video podcast for the one watching the podcast on YouTube. We'll add some pictures to better understand the heat maps you do create with that camera. So really visualization of sound. You told me that a lot of, I think something like 70-80% of projects are delayed because of any acoustic issues in building. So the pain is massive, actually. It's not just of someone complaining about the sound, but even in the preparation phase, in the building phase, it's a lot of delay and a lot of costs of
Yeah.
free work.
Especially when you approach the end of a construction project, people want to finish up the work and head on to the next project, and then in many cases the acoustic consultant comes in, measures sound transmission between rooms, tries to identify whether regulatory limits are met, and then the negative news is coming in that certain rooms or certain portions of the building are not up to the regulatory requirements. And this is where people have to come in and need to do the rework. And as you can imagine, there are many stakeholders in erecting a building, and it's many root causes that are on the table. That may be the eventual root cause that is responsible for not meeting the requirement. And this is why an acoustic consultant needs to know exactly um, where that problem is sitting and who eventually to contact to fix the issue, rather than going through a process of trial and error and let everyone come in and try to fix the situation, which obviously takes up a lot of resources, time, and money.
What you do develop is, we say, a sound camera or an acoustic camera, but if I get it right, it's more of a AI-powered microphone which you can connect to the camera even of your own tablet or of your own phone, right?
Exactly.
So it's kind of low asset. It's just a microphone. I know it's years of development, so just a microphone is maybe a bit tough, but it's only the microphone part you do connect to a normal camera. Can you
Exactly.
explain a bit more? Yeah.
Sure. So this is going back again to this concept of frugal innovation. That essentially the question that we asked ourselves back then was, what components are already available in the market? You know, that you can actually use or reuse for an acoustic camera. And what an acoustic camera essentially does is taking an image, recording a video, storing data, maybe sending data wirelessly from one point to another to get it processed. So a mobile device these days is essentially a commodity, and it's a standard device that everyone has, and that can be successfully reused for exactly that application. So and on the other side, of course, we also wanted to reduce the engineering effort on our side, you know, to select the camera module, to do all of the video processing and all of that, because it's, you know, it's available out of the box and you can reuse what's already available in the market. So the question more or less boiled down to, having a microphone module, only with a handful of microphone that is, in the end, it's a sensor stick, you could call it, that is rotating and scanning the sound field on a circular disc. And that's actually that's like your minimum requirement that you have. You need to somewhat record the sound events. And as I said before in my introduction, you cannot really, with an acoustic camera, you cannot only record those sound events with microphones that are only a few centimeters apart, but you need a much larger measurement surface that you need to cover. So that was actually the component that we developed. So a rotating microphone stick that is wirelessly sending or transmitting that data to a mobile device. And that mobile device eventually sends the data to the cloud for doing the number crunching work and for doing the heavy data processing. And eventually you get your data back from the cloud and do your analysis on these acoustic images.
So this rotating stick is capturing sound reverbing against walls and materials, and because you calculate how it rotates, where it's come from, you identify the exact source of a noise. You do some diagnostic based on, I guess, an AI-driven diagnostic to analyze this data and really mapping this on the picture you see on the camera.
Yeah. I mean, from a mathematics standpoint, it's as you can imagine, very involved to kind of capture the audio data with moving microphones. So you have a lot of nasty effects included there with Doppler frequency shifts and so on and so forth, which you need to compensate for. But on the other hand, when you compare our product to traditional acoustic cameras, which are essentially based on a wealth or host of dozens of microphones that are sitting stationary on a measurement surface, we have the advantage of moving microphones, meaning that we can capture the sound field at very, very many locations. So this is a key ingredient to getting high quality acoustic images, because what you eventually want to do is, as I said before, you want to capture the sound field at very diverse locations, which are far apart, and also at very many positions. So these are really the two ingredients that you need in order to get up or achieve acoustic images with high quality. This is essentially how our system works. So you have a stick that can range from a length of maybe 25 centimeters up to 1.5 meters. So you can also capture very large measurement surface having a diameter of more than 2.5 meters, where you can really go down to those very low frequencies. And at the same time, you can capture that sound field with only a handful of microphones, since those microphones are moving and capturing the sound field at very, very many locations.
As an investor, I love asking the same question every time. Why now? Why is it the right moment? And why such a solution doesn't exist or didn't exist before? Is it thanks to the AI part of it, algorithm you've built behind it, the sensibility of the camera, of the microphone? Why is it a perfect momentum for you to develop Sevenbel?
Yeah, so there were a lot of technological parts and pieces falling into place. The first thing was certainly the advent of, mobile device technology. Prior to 2010, I think, and even 15, it would have been very difficult to even think about or develop that solution, because mobile devices were not that widely available with that level of performance that is required. Today, you would like to have a very nice high resolution camera. You would like to have a video camera with a high frame rate. You also kind of acquire data, audio, multi-channel audio data at very high data rates using a wireless connection. And at the same time, there was also a lot of progress on the microphone side. So also, again, with the advent of mobile device technology, microphones have been miniaturized. They became very small, with also very good performance. So it was eventually possible to build up such systems at acceptable cost. And the other technological piece that also came around at this particular point in time, so it was at around 2015, was cloud computing eventually. Traditional acoustic cameras still use what is called ASIC technology. So these are dedicated application-specific integrated circuits that do the number crunching work. And these are typically processors that you have to develop, in a multi-million euro project in order to eventually come up with such a solution. And what we did is we sent that data that we acquired with only a handful of microphones. We sent that minimal set of data to the cloud, do the number crunching work in the cloud on high performance computers, and leverage that architecture. So to sum it up, there were many things on the software and hardware side falling in place, with the advent of mobile device technology, with the advent of miniaturized microphones, and also with the advent of cloud computing, that eventually helped us, or eventually made the implementation of that concept possible.
That's great. Tell me, Thomas, what the level of of precision, of sensitivity of such a solution, you're able to identify, to localize sound or noise in a room, in an office, for instance. You said that in any building. Are you able to identify what piece of an engine is noisy, or what piece, I don't know, what piece of a watch is noisy? How small can the analyze be in reality?
So let's take a standard example, maybe from the automotive industry. So let's say you have an so now with the e-mobility coming up, there's obviously a lot of analysis happening around e-powertrains, so electric drives and motors and associated gearboxes. And so let's say you have an object, maybe a length of 50 centimeters or so. And if you have a specific sound emission, maybe annoying sound emission from that part at around couple of hundred hertz or maybe 1 kilohertz, the blob or the size of the source that you can potentially locate is only a couple of centimeters. So you can really specifically pinpoint to what the actual root cause of the sound emission is. And when you develop a gearbox or an engine, in the later stages of the project, engineers also develop special acoustics packages or solutions to kind of dampen the sound emissions from the product. So they need to understand where to specifically apply absorbing material. And you want to do this in a manner not to totally destroy the thermal management of the entire system, because if you kind of surround or put absorbing material all around your gearbox and your e-drive or your engine maybe, the thermal management may be totally out of balance and the whole thing may be getting too hot and not meet the performance that it's required to do. So in this case, it's very important for engineers to understand where to specifically place that material very effectively with little surface only. And this is exactly where an acoustic camera helps, because it clearly pinpoints, where those sound emissions are happening. And you can think of it like a Band-Aid that you would then just apply to where the product is emitting sound, and while still maintaining thermal management household.
Last question, Thomas, for that run of Q&A. I think you already have more than 200 customers, great growth. But what's on your roadmap for the next years? What in terms of product development? Where do you want to go in the next years?
Yeah, so we have a lot of ideas in our funnel, so to say. What we see a lot happening these days is that engineers and technicians, they want to work very effectively. So they don't want to necessarily waste their time, with analyzing data in great detail and pushing a lot of buttons and looking at a lot of diagrams. So this is actually where AI and analysis of the data is coming in. So we want to support our customers on this path to eventually show them the data that is relevant so that they can make grounded technical decisions on their end. Because you also see it in your daily life. Things are getting faster, quicker nowadays. Most people are already working with ChatGPT in their daily life. So things that typically consumed maybe 15, 30 minutes, 1 hour, or even more in the past, can now be done within a couple of minutes, with the support of these tools. And this is actually the direction that we are also going. So we don't want our customers to waste their time with raw data and a lot of diagrams and digging into the nitty gritty. In the end, they are interested in solutions and how to fix their issues. An acoustic camera in the end is a troubleshooting tool. So it should help you in getting to your final conclusions and final measures quickly. And this is where we're putting a lot of effort into, try to understand how we can abstract the complexity of the data that an acoustic camera produces, to abstract that flood of data away from the end user, and support him in trying to understand what's going on and how he can make those decisions more quickly. At the same time, of course, this is on the product side. At the same time, we're focusing on specific industries where we see a very good traction of our product, which is certainly the automotive industry, but also the construction industry.
Okay. Yep. It generates a lot of questions, but let's switch to the discussion round to keep a short podcast episode today. Thomas Rittenschober from Seven Bel, thanks a lot for your first answers, and we switch now to the discussion part. Thanks a lot, Thomas, for your first answers. As I said at the end of the Q&A part, it generates a lot of questions to me. My feeling is that even with great technology, we still need to convince people to use more and more that kind of technology to identify noise and to fight against noise. And the feeling is you make it more available, at least in terms of speed. It's quite fast to analyze sound. It has to fit the economic equation of the construction company, of the manufacturing company, that they really work on it and find the right solution. And I think it really helps. So is it the awareness good enough? You would tell me it's never good enough, but do you think it's only a question of awareness that industrial companies better solve noise issues? It's just a question of awareness, or do we still need to go farther in terms of technology?
Yeah, so that's certainly a good question. To some extent, you see over the last couple of decades a lot of pressure building up on the regulatory side. I mean, manufacturers of products need to meet certain noise regulations, maybe for vehicles, for construction equipment, also inside a building for the well-being of people. There are regulations available, and when this pressure is building up, and you see it currently, with e-vehicles coming up, that the noise emission thresholds are kind of being lowered. No fueled, of course, by the introduction of new technologies, but it's still challenging, of course, then for manufacturers to meet these requirements. And this is exactly why they need the instrumentation, why they need measurement instruments, because as a human being, it's very difficult to understand, when you are kind of over that limit, to know where that sound is exactly coming from and what you need to do about it. So this is one side of the story.
Fighting invisible noise is quite frustrating for a lot of even professionals. You're like frustrated not to identify the best way to do it. And again, I'm not sure it's solved by the economic equation of such companies. Just a point about the mobility part, because you say that it's something I hear a lot, and I discussed that point in other podcast episode too. But electric vehicles or electric motors for e-vehicles is not solving the mobility noise problem we have, because the engines before were already in the right norm. So sure, we can reduce kind of a white noise, kind of a background noise, but in terms of damaging noises or harmful noises, most of this noise come from the contact between the wheel and the road, or brakes, or other pieces of mobility, and not the engine itself. And a lot of people think we will reach our European target of reducing noise emission in mobility by 30% until 2030. The fact is, for now, we're the most optimistic cases will reach something like 15 to 19% of reduction if electric vehicles are really raising the way it was in the last years. 2025 is a bit both, but in the last years. So I think we still have a lot to do. Just taking that part, because I think a lot of efforts are not made because people think it will be automatically through electric vehicles, and it's not the case. So we still need to find other solutions. Part close. But my first reaction as I heard about you as we met the first time, it was the market is not big enough for the market. Specific market is not big enough, but when you see the cost only for construction and real estate, and you spoke about automotive and engine, the market is huge because it's a daily issue of so many companies, and rework is just costing a lot of money. So that's really I can't understand why it's not used by like every construction company in every part of the solution.
Yeah, I mean that pressure is actually. I mean it's a process in the end, and we are kind of observing the process, and we see that that pressure is building up. I will talk about the construction industry maybe a little bit, and also automotive industry. But what you see on the product development side, and that's not only cars, but also other types of products. Maybe lawnmowers, power tools, etc. What you see happening there, that it's no longer not only the responsibility of the manufacturer of the product, but that responsibility is also trickling down now to suppliers. In the sense, that when a new product is being developed, that for many years and decades, acoustic requirements have not really been passed on that well to suppliers and suppliers of components to the final product, because it was more regarded as a final responsibility of the manufacturer to integrate everything, essentially try to understand that the coupling between all of these components is understood, and that the final product meets the requirement and meets the requirements and is as pleasant as possible. But we see a big change in this area happening now, coming from the fact, that these noise levels are being constantly pushed down to a lower limit, and that makes it very hard for engineers at the integration level to meet these requirements. And this is exactly where these responsibilities in the form of requirements are now also being forwarded or being trickled down to the suppliers. And this actually, of course, widens up the market for this type of measurement instruments, which is good. But coming back to your question about awareness, so this is exactly what is now happening in many industries, that suppliers of components who previously just were responsible for the function of the component itself, meeting, traditional performance parameters, now also have to worry about the acoustic performance, meaning that these components per se have to meet certain requirements at the component level to be sure that there is enough margin that at the integration level, when all of the multiple components are stick together, and that the final sound emission, so to say, is being met.
I fully agree with that. As I started deep diving on no noise and better understanding what noise is, or it disturbs us finally, I've been on a construction site, and I try to understand what piece of noise is disturbing the area, the residential area. And then I spoke to acousticians, and I discovered that the full value chain of developing an engine, each piece of this engine, putting it in a heavy vehicle, and the full chain until the resident, until the habitat, which is disturbed by the noise. It's, I think, something like 8 to 12 different stakeholders having to take the right decision in terms of capturing sound and of stopping sound. So making it available for each stakeholder and putting even some responsibility at supplier level is, in my opinion, for sure helpful, because if you have 12 different stakeholders, what's happening mostly is that's not my part. That's just because my supplier didn't provide the right solution. So is everyone responsible for that with regulation, but I think with market pressure more in general for sure to help. Just a word about cities. I see in many cities noise is a big issue, and localizing noise is a big issue as well. The city of Paris, with the regional association Bruit Paris, developed their own acoustic camera to identify where a noise is coming from at a corner. Is it a market for you, cities as well? Are you able to cover that market? And more generally, why don't you put your solution in Paris, or maybe you have your solution in Vienna? I don't know, in Vienna. So what about um, the B2G market?
You know, the nice thing about being a manufacturer of an acoustic camera is that you have such a wide field of, where it can be actually used. But from a business standpoint, it's at the same time very difficult to focus on the areas where you sense or feel most resonance from customers eventually. Having said that, of course, we know that there are companies, manufacturers of acoustic cameras out there focusing on these kind of infrastructure projects. So where it's kind of monitoring application where you put acoustic camera modules in certain locations and observe what's happening over time. And this is an area where that we could potentially enter because we have all of the ingredients technology-wise, but at the same time, you need to focus. And
Okay, so the
you
go-to-market
need,
is expensive.
yeah. I mean, it's when the product as we have it today, and we want to make it fit for that application. I mean, there's certainly some effort required, and it's not only about smart cities. You could also think about end of line quality control. You could think about automated maintenance of components. So there are a lot of applications, for an acoustic camera out there, and we try to find, our sweet spot where we think that there's a big enough market, and where we also have a competitive edge over our competitors.
And focus on your most evident go-to-market. That's for sure. So I fully understand that founders need to focus. I've been there. I'm still there. So I understand that point. I have two last questions before letting you leave and meet further customers. Ultrasound. Ultrasound is not a noise itself. It's really hard to identify to capture an ultrasound, at least for normal microphone. If you hear some ultrasound, it's disturbing you. You take your iPhone and you won't be able to measure anything. In terms of decibel, it's quite low, still very disturbing. Are you able to measure that?
Yeah, we have a sensor solution that also measures in the ultrasound domain. It's specifically used for locating compressed air leaks and partial discharge. So these are two types of sound events that are relevant to the industry. So when you have a production plant, compressed air is a medium that is used for operating a lot of and actuating a lot of machinery. And if you have leaks in there, it's like having your window open during winter time. So you're losing a lot of energy and wasting a lot of energy. So companies are really starting to focus on that a lot in terms of using acoustic cameras for locating compressed air leaks, fixing those issues, and reducing energy consumption over time. And it's really impressive. We do some of these measurement services ourselves, and we have a customer base using our equipment for locating compressed air leaks in their in their production plants. So since our system is modular, it can be both used in the audible range for occupational health and safety, for evaluating noise at the workstation or at the workplace. But at the same time, you just swap the sensor module and you can do the same measurements in the ultrasound domain. And when you walk through a medium-sized production plant, you can easily find some 10 to 50,000 euros per year that you can save by just fixing those leaks. So it's really amazing.
That's great to hear that in terms of technology, we are at some place we can solve a lot of issues. I end this episode with the last question about technology. Do you think at some point we'll be able to measure everything with something like that? We're not using big microphone is maybe not for you the right market if you tell me we will be able to replace a microphone, but the question is more, are we able to make some portative solution at some point and make it really available for everyone quite easily? Because it's still a project to measure sound the way you do offer. It's high-end, I understand that. It's way simpler than before. Still, it's not every consumer is able to use such a solution. So do you think at some point we make it portable, really portable?
I think so. It depends on, again, what applications you want to cover. As I said in my introduction, the challenge is, what noise sources you would like to locate. In many cases, we feel annoyed not really by the medium to high frequency sound sources, but by the rather low frequency sound sources, like fans from heat pumps, traffic noise, etc. And in this particular case, you just need to solve the problem of how you can capture the sound field with microphones being very far apart. And if the technology is not going into the direction of, making mobile devices even larger, then that's the thing that needs to be solved. But looking into the future, I'm always optimistic, and I think that miniaturization will happen at some stage. And we also see it already happening in our industry. We have applications like the one with locating compressed air leaks, for instance, where the sound events are happening in the ultrasound domain. You can already use very compact systems that you could even integrate into a mobile device at some stage, with all the software, with all the hardware, etc., to do the job. And I certainly see this coming over time, maybe not for the full range of applications and sound events that we want to locate, but maybe for some.
Thomas Rittenschober, founder and CEO of Sevenbel, sevenbel.com, sevenbel.com, one L only. If you want to have more information about Sevenbel, great style actually. We didn't speak too much about figures, but more than 200 customers. You told me you have a growth rate almost at 70% per year, which is kind of impressive as well. So I think the future is nice, where I see that technology is meeting the need we have in a lot of industries, and I think it's really important to measure it right if we want to solve the noise issue we have, to fight against noise. Thomas, thanks a lot for your time today. It was a pleasure to have you, and let us know what are the next step of Sevenbel at nonoise. We'll be really happy to make some noise about it.
Thanks again very much for having me on the podcast. It was really great talking to you.
See you soon, and bye everyone. Thanks for listening to this episode, and don't hesitate to share it with your community. If you think it can be interesting for someone, just do that, and give us, please, if you like this episode, 5 stars on your favorite broadcasting platform. It will help a lot to, as I said, bad joke, make some noise about no noise, and make some noise about fighting noise, because I think it's a question of community. Thanks everyone, and see you soon.